Hello folks, welcome to EvolvNext. In this video, we would be exploring Pandas library in Python. So if you are someone who is looking to learn Pandas from scratch or struggling with the basic concepts in Pandas library, then this video is for you. In this video, we will cover data inspection using Pandas, then data selection and indexing using Pandas. How is data cleaned in Pandas? We will also have a look at how data is transformed and it is reshaped using Pandas library. So let's jump in. We would explore the functions and the attributes of Pandas that are required for data inspection, along with the introduction to Pandas. So let's start. What is Pandas? Pandas is nothing but a powerful Python library that is used for data manipulation and analysis. It contains two main terminologies, that is data frame and a series. Data frame could be thought of as a spreadsheet or similar to SQL table, which contains two-dimensional label data structure. Okay, along with some columns, it may be of different types. Then there is something called as a series, which can be thought of as similar to a list or column in a particular table. So let's jump into the Colab notebook. So Pandas doesn't come up installed by default along with your basic Python. Okay. However, in Colab it's already installed. But if you are doing something on your machine or your machine won't have Pandas installed, so you will have to install Pandas and then import it. After to import, we have this command import Pandas as PD. PD is nothing but an alias name. So to demonstrate attributes and functions of Pandas which are required for data inspection, I have taken this data set called as movies. All right. So how do we read the data? We use pd dot read underscore csv. If it is it's an Excel file, it will be a different function. It will be read underscore Excel or something. So it depends what kind of data are you looking for. Then I have a function called as df dot head. Let's see what it returns me. Okay. If you could see here, it returns first 5 rows of the table so that you can have a look at it. Like in this particular case, we have movies. So there is a movie ID that is mentioned, and there's a budget, popularity, revenue, a title of a movie, vote average. This may correspond to the rating, vote count, then a director ID, year, month, and day. So you can have a glimpse of what data is there in the data set with this particular df dot head and using df dot head function. Okay, so if I want say 10 rows, then I will just mention df dot head, and whatever number of rows I want, I can mention it here. So you would see this time around you will get 10 rows. Okay, first 10 rows. By default, it returns you first 5 rows. However, if you want to get more or any other more number of rows or maybe less number of rows, you can mention that number inside the parenthesis. Okay. Then similarly, you can also get last few rows. That is, if I do uh, df dot tell, this will give you last 5 rows by default. Okay. So you would see here these are last 5 rows. Then uh, there is something called as df dot info. Right. You would see what this will give you is the information about the data that is there with you. That is, it will give you what kind of data type it is. That is, it's a data frame, because whatever table like structure in Pandas we call it as data frame, and for a particular column we call it as series. Right. So it gives you the information of each and every column. These are the column names. Then it gives the non-null count. So there are total of 1465 values, and there is no null value inside it. And there are three types of data types in Pandas, that is int64 or integer, float, and object. Okay, and no other. So if it is the data type should be either integer or float. If it is not that, then it will be considered as object. All right. And moving ahead, let's see. There is one more function, df dot describe. What df.describe gives us is the statistics for numerical column. So you would see here for all the numerical columns, it has given me the statistics like count, mean, standard deviation, minimum, maximum, then the interquartile ranges, and so on. So um, if I want, you would notice here though that it's only doing all this stuff for numeric columns. However, if I want to include the object data type as well, I will have to do a include all. So df dot describe. Okay, inside the parenthesis, I would mention include is equal to all. So I run this. you would see there are few more rows added over here, like unique, top, because those are of object data type, right? You cannot calculate mean for that. See here, look at this. For title, you cannot calculate mean, right? For month, you cannot calculate mean. So for all those non-numeric columns, cannot calculate mean. That's the reason you get the output of you get this kind of output. That is, look at this mean, standard deviation, minimum, all these ranges. It's not possible to calculate for what? For object data type. So I hope you understand what I mean by uh, object data type. It's a data type that doesn't have integer and float. Okay. So moving on to our um, next attribute that we will be checking is we remember describe when I'm using this parenthesis. These are all the functions, all right. And I would also be showing you some attributes now. Like if I type in df dot d types here, it's an attribute. It will show all the data types, like data types of all the columns present in the data. Okay. So columns, or in terms of pandas, all the data types of the series that are there in the data frame. Okay. Then df dot index. Let's see what df dot index gives you. So it will provide you with the range of where the index starts and where does it stop. Okay. After that, if I do df dot columns, it should return all the column names. Then there is something called as df dot shape. It will give me the shape of the dataset, that is 1465 rows and 11 columns. Then moving ahead, this is what are we doing by checking all this? This is something called as data inspection. So we are inspecting the data. We are checking all the uh, all the parameters of data with respect to inspection. So next one is I would like to check if there is any null value, and also doing a sum of that null value. What will this return me? Oh, so there is null is a function. Yeah, you would see there is no null value. Otherwise, it would have returned me column wise sum. Okay. However, there is no null value here, so I don't get any output for this. So that is fine. Now moving ahead, let's say I want unique values in a particular column. So I would take this in our data. I would just take this to a df again. So I want unique values. So I will check it on year column. Okay, because I want unique values. Now in the year column, how to get the unique values? There is a function called as unique. So df, then that column name. Who's that column name? Year. Year. The function is unique. Look at this. These are all the years that are present in the data. Okay, these are all the they are repeated, but I have got the unique values. So in our data, these are all the years that are present. Then moving forward, if I want the count of unique values, what is the count of these values? Then there is one simple change here. Instead of unique, you just mention n unique. So it will return you the count. There are total of 41 unique values in the year column. Then if you want to do a value count, then you can do that as well. So df dot year, same thing, and I will do a value count. So value underscore counts. Okay. Oh my bad. It's a function. Look at this. So it will straight away give you which year appeared how many times. All right. So it returns the count of unique values in a particular column. Look at this. Yeah. So 2006 appeared maximum times in our data, then 2005, then 2002 accordingly. Let's move ahead with the next one. If you want some random rows from the data frame, then you can mention df dot sample random rows. How many rows do you want? Say you want some 8 random rows. So this will give you any 8 random rows. You would see, you would identify that with the index of the data. The indexes are very much random, so they have picked any random row. So that's about data inspection part for pandas. Now let's move ahead with next topic. We will discuss how can we select columns from a particular data set, or maybe it may be a single column, it may be multiple columns. Then we will have a look at what is implicit index, what is explicit index, and using that how we can select specific rows from a particular data set. And then we will also see how we can select data based on conditions. So let's jump in. You would see here the first statement is import pandas and import numpy. So this is quite familiar to you. Now it's been like we are 4 to 5 videos um, old in exploring Python libraries. So this is something that is familiar to you. Then I have uh, imported the dataset movies with the read underscore CSV function, or you may use some other function. If it is a XLS file, it will be read underscore Excel function. Then I would just like to have a look at the existing data. That's the reason I am using df.head. Oh, my bad. Here, to run this cells, df.head. Now you would see this data consists of movie ID, budget, then popularity, revenue, title, vote average, vote count, and all these things, like director ID, year, month, and day. Okay. So we had a glimpse of what is there in data. Suppose I want to have a look at only one column, or I want to select only one column from this particular data. What would I do? I would simply enter the column name inside um, inside the existing data, and I would select it with this syntax. I would simply write df, then square braces. Inside that, I will write the column name. And if I run this, you would see only one column will be displayed. Okay, this is the output that you get. If I want to select multiple columns, same thing I will do, but this time I will have to specify whichever columns I need. I would have to specify their name. All right, so I needed title and vote average, so I mentioned their name in a list. The syntax is the same. Instead of single column name, this time what we have done, we have entered a list of number of columns. Like we want to select 2, you specify their names, and the data will be displayed. All right, now there is something called as implicit and explicit index in pandas. All right, so let's see what is implicit and what is explicit. Now implicit index is represented by ILOC, and explicit index is represented by LOC. Explicit index is an index which you can see here when you get the output. If you have noticed, this number here, this is not a part of table. All right, this is something called as explicit index, because as I mentioned, you can see this, right? It starts from 0 and it goes all the way till 1464. Okay, you would see here as well. So whenever you try to see a particular data set, data in a particular data set, then you would see there is one additional column, you may say, which doesn't have name here, and that is nothing but an index. Okay, this is not a part of our existing data. Okay, this is not a serial number, or I have not forgotten any column name over here. It gets generated, and we can see that, and that is nothing but called as an index. But it is an explicit index, because I just mentioned that explicit indexes are those indexes which you can see over here. And what is implicit indexes, which you cannot see, but they are there, they are getting generated in the background. We will see what it is when we have a look at the example. All right, so if I do df.iloc of 1, let's see what is the output. You get an output of the you get an output as a second row, because you mentioned df of 1. 1 is at where? Here. The 1 means the index, right? So the data corresponding to the index 1 is displayed. Now this is ILOC, and when I do df of LOC, df.loc 1, which is explicit, this again shows the same data. All right, then you would wonder, hey Vishal, these both are showing us same data, then what's the difference? Yes, of course there is a difference. That's the reason we are studying this. All right. Um, Suppose I want index to start from range 1 and not from 0. By default, it started from 0. Explicit index starts with 0, and even implicit index starts with 0. That's why we got these similar outputs. However, we can change explicit index range, and we can start it from wherever we want it to. Now, suppose I want the index to be started from 1, so I have used this range function, and using it inside list function, I have modified the index. I want the start to start it from 1, so this is what I did. I gave 1 and the range till where df dot shape of 0 plus 1. You would say, what is this df dot shape 0 plus 1? So it is nothing. Let's explore df dot shape first. So df dot shape gives you what? Shape is 1465 and 11. And what I have done, shape of 0. Shape of 0 in the sense this number 1465. So if I do, oh, hold on, mistake, and I just click this. Yeah, df of shape of 0, if I do over here, okay, you would get 1465. All right, and plus 1 is 1466. Okay, so my range should go till from 1 to 1466. Only then I would be able to get 1465 rows. You remember the range function from the for loop that we discussed. We had discussed range function when we studied for loop. All right, so that's how it works. The range will be from 1 to 1466, wherein 1466 will get ignored and you will get all the 1465 rows. Alright. So to proceed ahead, now if you look at this, the index started from 1 because we wanted the index to start from 1 and not from 0. So that's an advantage of explicit index. It will take the range from the one you want it to be. Okay. So now if I do df.loc of 1, look at this. It will give me first row, not the second one as we used to get earlier, because the index has changed. And at the first row, these are the details, and those details will be shown to me. However, if I am still using ILOC, right? Let's see what I'm getting. This is implicit index. It still returns me 2 because we cannot change. Implicit is this index we cannot change. All right. It behaves the way you can relate it with the Python indexing similar way. Whatever we have studied earlier, while we did string slicing, while we did list slicing, so at that time we had studied positive indexing and negative indexing. It is that index. All right. So which whatever is the default behavior, by default which index operate, that is the same index referred by ILOC over here. All right, you would see it did not change. Now if I do a df.iloc of -1, okay, now you would quickly answer, Vishal. It will give us the last row of data because you are already aware what is negative indexing. Okay, after that df.loc of -1. Let's see what this gives me as an output. And yeah, this gives me an error, key error -1. Why do you think would this have happened? If you look at this carefully, df.loc of -1 right now in the LOC or in explicit indexes, what I have is a range from 1 to 1465. All right, and these are explicit indexes. So whatever range I had already mentioned, whatever range I want, I would be specifying there, right? So I have a range from 1 to 1465, and I'm trying to give -1 in LOC. So there is no -1 in in this explicit index range. It is from 1 to 1465. Had I mentioned -1, then this would not give me an error. Look at this. It is giving me a key error. It's saying key error -1. Um, we don't have this key. We don't know what this key you are talking about. So negative indexing and positive indexing will apply only in terms of um, uh, ILOC. I mean both will apply only in terms of ILOC. Explicit index, that is LOC, it will not apply because that is something that we have given. The range, whatever item or whatever row you are trying to reference should be from that same range. That's the reason we get an error here when we give something that is not there in 1 to 1465. All right. Now, if you want to see a particular index, then you can see that index as well. All right. Now let's have a look at row selection using implicit and explicit indexing. Here you would see df dot loc 1 colon 10. All right. So ILOC1 means which row of using explicit index, it will be second row. Second row, why second row? Because um, I'm talking in terms of explicit index. Why I'm trying to explain this is because, see, the data, these indexes are explicit indexes. What I'm saying, ILOC of 1 is equivalent to explicit index 2, whatever is there in explicit index 2. ILOC of 0 will be equivalent to explicit index 1, because we have changed the order of explicit index and it now starts from 1, right? And that's why it started here from 2 and it went all the way to 10. Okay. Now if I would have written 0 over here, look at this. Now it will return me the first row. Look at this. It returned me from the first to the 10th. All right. So this is what we should be able to actually notice. And if you see 0 to 10 is 11, right? If we count, but it follows the range concept here as well, and it returns you how many rows? It returns you rows from 1 to 10. That is, number of rows written here are 10, not 11, because the 10th one is excluded. This is very much the same when we did slicing um, in strings or list. All right. So I always keep on referring to the to our older concepts, because you will be able to correlate very easily. All right. Then df.loc of 1 to 10. Now if the same thing I want to do it for loc from 1 to 10, then what's the result? Look at this. It starts with 1. Now we are telling the interpreter that okay, use loc, right? So loc, I said, will follow whatever range we have specified. We have specified 1 to 10. In this case, it will show all 10 rows. Now it doesn't ignore this 10, and it doesn't show only 9 rows. In this case, in case of loc, it shows all the rows whatever you mention over here. So these are few key things that you should remember while you explore explicit index and implicit index. The way ILOC and LOC works is totally different. In LOC, you can change the range of the index. That is, it did not necessarily start from 0. You can mention whatever range you want. And the way it works is this: whatever you specify in the range, it will take all the rows. It will not ignore the uh, upper limit range. And in ILOC, it will always give always retrieve one row less than what you have specified, because it is similar to the to our range function. All right. Now if the same thing, if you want some specific rows, you have to mention those row numbers, or not the row numbers, you have to mention the row indexes. And this is what we have done here. Df is equal to ILOC 1, 12 and 18. You would see 1, that is the output that will be replied by this first element in the list is this row, that is the second explicit index row. Then the 13th explicit index row, because you have mentioned 12, it will always be one more in terms of explicit index. Guys, again I'm saying, don't get confused. Explicit index, you can see, that's the reason you see this 2, 13 and 19. Implicit index you cannot see here on the screen, but we can um, definitely correlate how these things are working. It doesn't show you the exact first row details because you haven't put 0 over here. Implicit index will always start from 0. It will have negative indexing as well, wherein explicit index doesn't follow any thing kind of negative indexing as such by default. If and only if you mention some negative range in um, explicit index, only then it will follow. All right. Then df dot loc um, 1 comma 12 comma 18, then exact same rows will be retrieved. See 1, 12 and 18. All right. Now let's move on to the next section, that is condition selection and filtering. All right. So based on condition also we can select particular number of rows or specific set of data. Here I wanted to have a look at movies which have vote average, or you can say which have rating more than 6. All right. So what I have used here, I have use the comparison operator greater than and try to do the same. However, if you notice, we get an output as a Boolean array. The output is true and false. It doesn't give me the actual data. Now, if I want actual data, what I will do, I will apply this Boolean array on as a mask on my original data. So my original data is df, and I simply put this Boolean array on the original data, and this will actually retrieve the values. So wherever it is true values or those rows will be retained, and wherever it is false, it will not show up here. That's why you see there are 977 such rows which have rating greater than 6. So if someone asks me that which are the movies that are greater than that have rating than 6, then I would simply use this. But no, kindly note here that the output that you get by comparing it with whatever number you decide, whatever rating you decide, was Boolean. It gave you true and false output. Now, to, we are not interested to see what all data is true and false. We just want to filter out, or we want to select whichever movies have rating greater than 6, and that's the reason we applied that mask on our data set. This is also called as a fancy indexing, sometimes also called as masking. So these are various different terms that are used for the very same purpose. Now, if you want to do a mean of particular thing, I mean, let's take the same rating column, or you can say vote average column. And I'm saying it as rating because vote average here shows the rating of a particular movie. So if I want to take an average, what I will do, I will first select that vote average column. I will take it out and store it in a different variable, and then I would take a mean of that. So here I just have done the same. To get this, I get the vote average. I just selected the column. You know how to select columns. If I want to take a mean, I can always take a mean of that. Now let's move ahead with next topic. We would see how to identify the null values in a particular data set, how to fill them up, and how to drop a particular column with null values or a row with null values, and also how to explicitly drop a particular row or a column from a data set. And we will also identify the duplicate rows that are there in the data sets and drop the duplicate rows using different variations. Now let's jump in. You would see first line of code is I have imported pandas and specified the alias name. This is something that you are already aware from the previous videos. Then moving ahead, I have data which is there in this file film.xls x, and I have loaded the data in the data variable. Now let's have a look at what is there in data. So we have movie ID, title, genre, then release year, rating, director, and runtime. All right. Now I need to identify which all null values are there. So I have a function called as data.isNull. So if I use this function, it would return true wherever there is a null value. It will actually return the table containing true and false values, and wherever there is a nan or a empty value, you would get true. At this point of time, our data is short, so we can easily have a look at this. You have got true in this release year and the column rating. All right. However, if data is larger, you may not be able to see this very easily. That's the reason um, we would do a sum of true values in a particular column. For that, we have just a sum function to be attached to data.isNull. All right. So this is the way we write. I have a variable null values is equal to data.isNull.sum. That would give me column wise count of how many null values are there in particular column. From this output, I can clearly understand that release year has got one null value and rating has got one null value, and I need to do some treatment with that. Please understand, we cannot just leave those null values, or we cannot just replace it by anything we want. We need to think about how the data is, what number of null values are there for our data is it some substantial number of null values or it's a ignorable one, and accordingly we will replace those null values. Now here you would see I have replaced it with median and mean. In the release year I have replaced the null value by median, and in the column rating I have replaced the null value by mean. Now first let's see what does um, the output of data release year dot median gives it to me. Okay, so I'll just take this part of the code, see what is the output that I get on doing a median of releases. So I get 2011. So have a look at data rating dot mean, 8.100. All right, let's have a look at data one more time so that you can easily compare after we replace the null values. Now here you would see rating has got one null value and release year has got one null value, as we have already seen. All right, now look at this. The release year dot median turns out to be 2011 and rating turns out to be 8.1. So these values should be replaced accordingly. Like for release year, instead of this 9 we should get 2011, and rating, in the rating column, instead of this 9 we should get the value 8.10, that is the mean. And if you want to replace this, we have a function called as fill in. Okay, that's what we have used, and we are trying to replace it. So we just need to mention a column name and by what you want to replace. Do you want to replace with median? Do you want to replace with mean? Or even then, even it is more to it, we can also do a replacement with something called as mode. That is the value, that is the particular null value or empty value will be replaced by frequently used value in that particular column. Okay, so we are not using that one here, but we are using median and mean. All right, so let's see what's the output that we get here. You would notice that wherever there was null value, it got filled with 2011 as expected, and um, in the release year and in the rating, we got it. We got the null value replaced by 8.1. So it depends on which option is suitable for you. Is it median? Is it mean? According to the data that you are working. Okay, you cannot simply ignore and go on deleting things. You will have to replace at times using mean, median, and mode. All right, and if there is a text column, you would say, hey Vishal, that doesn't work. The mean and median doesn't work. So you can simply write some text like not available, not applicable, NA, whatever you wish to. I understand, because those will be like strings. You cannot take any mean or median on that. All right. Moving ahead, if you want to drop particular rows which have um null values, then you can simply drop it. So in this case, I have I had null values on fifth row and sixth row. Let's see if they are getting dropped. Yep, see, fifth and sixth row are dropped. Dropping is a good option when the number of rows with null values are very less compared to the data, the number of rows in the entire data. Say you have 10,000 or 1 lakh rows and only 3-4 rows have some null values. You might prefer dropping those. Then we can also drop columns which have null values. So we have the same function here. We should specify the axis. So axis is equal to 1 states that you are looking for dropping columns. When you don't specify anything, by default it takes as rows. All right, so here if you would see, those columns are being dropped which had null values. Okay, so there may be situations where you don't need those columns, then you can use this option. Else you would prefer doing a filling those values, right? Then irrespective of null value, will you be able to drop a particular column? Yes, that is very much possible. If you want to drop a single column, just mention the column name, mention the axis is equal to 1, and you can very well drop it. I dropped runtime from data. Look at this, I don't have any runtime column. Why we are looking at this is because when we receive data, you may think particular column is not required. Then in that case, you will just simply drop that column and prefer only the columns that are required. So for doing that, you will use this. You may also want to drop some rows. You can use this indices to drop rows and mention access is equal to 0, and you would not see row 6 and 7 which are mentioned in the drop statement over here in your data. So if you want to delete any specific rows, that is very much possible. And now dropping duplicate rows. First, to drop duplicate rows, we need to identify if at all are there any duplicate rows in the data that we are looking in. All right. So let me check if we have any duplicate rows first. Look at this. You have a duplicate row at index 8 in data. All right. So it duplicates. Let's have a look at data again and see which row it duplicates to. Just type in data over here. Yeah, see 7 and 8, last two rows. These two rows are duplicate. They have duplicate data. So what we will do, we'll try to remove duplicates. Now, if we want to remove both of the rows, then we will have to keep this parameter keep is equal to false. Okay. In this case, both of the rows 7 and 8 will be deleted. That is 7 and 8 is the index number for that particular row. You would see only 6 rows. However, if you want to keep the last one, that is the 8th one, then you just mention last over here. Then the 8th one will be kept and the other one will be deleted. Or in case there would have been 3 4 rows, the other rows would have been deleted and only the 8th one would be retained. If you keep first over here, if you mention first in this key parameter of the drop duplicates function, then you would get the first row that will be kept and the others will be deleted. So this is how you perform data cleaning in Pandas. Now let's move ahead with next topic. We will have a look at um, how to actually transform the data. That is, how to change the data type of a particular column, then how to rename a particular column, then how to add new columns, modify a column, add a row, modify rows, then how to set index and again reset index, and how to group and aggregate the data in a data set. Then also we will have a look how to apply functions to a particular data frame. So let's jump in. Our first statement, as usual, import pandas as PD, PD being the alias name. Then I have data set called as transform underscore movies. Well, I forgot the S over here, but it doesn't matter. So when I load this database and I try to see what is there in database, you would see some 10 rows there. I kept it as simple as possible. I'm not taking a lot of rows here. So you would see here the data consists of movie ID, title, then release year, genre, IMDb rating, budget, and revenue. All right. So let's check what are the data types of all these columns. For that, we have df.d types, which we are already aware. And we would see there are 3 data types that come in by default. That is integer, float, and if it is not both of this, it is an object. However, we have some specialized data types as well, in which we can convert. These are something that come by default, as we already know from our previous videos. Presumably, say I want to change data type of budget and revenue to float instead of integer. Then I have this function as type and I can change it to float. So if I run this and again try to see df.data types, then you would see here the data types are changed from integer to float. All right. Then let's see how to rename column in a data set. Okay. So if I run this, and before running this, I'll just explain the syntax. We have rename function inside which we have this parameter called as columns, wherein you can mention the column name and the name that you want to replace it with, and it should be in a form of a dictionary. If you're not well versed with how dictionaries work, we have a separate video in our Python for beginners series. You may refer to it. Okay. and I have also used in place. So these two columns I want to replace is the column is release year. I want to replace it by release underscore year. Then there is next column IMDb underscore IMDb rating. I would replace it by IMDb underscore rating. And in place is equal to true indicates that these changes will be saved permanently. You would see here the column names earlier were release year and IMDb space rating. So instead of space, by using this command, what should happen is space should be replaced by the underscore. So let's see if we are able to do it successfully. Yeah, look at this. Look at the output. We have successfully renamed the column. Now moving on to the next section, how to add a new column. There might be a need where you want to do some calculation based on existing columns and you want to add a new column to your data set. Now we have revenue and we have budget and we want to calculate profit. Now this calculation happens on each row, right? So that's the reason we want to add new column, and for each row, what is the profit we want to show it. And formula is pretty simple. It's revenue minus budget. However, look at this. By using this df and in the square base profit, we are creating new column. So let's see if that gets created or not. Yes, we are able to successfully create the column called as new column called as profit. Now, suppose you want to modify existing column. That is, if you want to explicitly tell the database that the rating should be rounded to 1. Okay, so if I want to do that, then I can simply write the code as IMDb rating dot round of 1. So round of 1 in the sense after decimal, after decimal point there will be only one digit. If you want to round it to 2 digits, or you don't want a rating, then simply use round function. That's it. I want to round it to 1. That's the reason I have written IMDb underscore rating df dot round 1. Explicitly I am telling that this column will only have uh, one digit after the decimal point, something called as precision. All right, so yeah, you would see IMDb rating being displayed as 9.0, 7.8 and 8.7. So all are displayed in the form of one digit after decimal. Now let's see how to add a new row. Now here you are adding it in the form of dictionary again. So we need to clear how we add how we create a dictionary actually. Then we have to convert that new row into a data frame first. If you directly go on to add using this concat method, it is not going to happen. First you need to convert it to the format of the data frame. That's the reason I have used the data frame function, and then you add it to a new row, and then you write ignore index is equal to true. Okay, the ignore index, because whenever you add new row, it starts from new index, that is it starts again from 0. So if you see here, new row would be added easily. Okay, at the 10th index. All right, if I don't write ignore index here, it will simply start the index from 0. If you would notice, look at this. Look at this. We don't want this to start from 0. We want this to start from 11. That's the reason we write it as ignore index. Now moving on to the next section. You would see here earlier when we used, before moving to the next section, you would see here earlier we had used ignore index. The index got adjusted to 10. However, when we removed it, the index again started with 0, which is something we don't want. All right, we want to maintain the indexes. That's the reason we ignored it. And then if you want to modify a particular row, even you can do that. Look at this. I have just mentioned the location. These are the explicit indexes. So I use the explicit index 6, and on the explicit index, whichever value is there, I'm just trying to modify. So instead of 2014 over here in our data, I am trying to take what? Let me show you the data first. There in our DF, this is what we have in DF, right? And I want to change it. Change the year 2000. Instead of 2014, I want to mention the year 2015. So what I would do, I would simply come here and mention the index as 5, and I will try to change this. So look at this, the year has changed. So if you want to change a single value also in a particular row, you can definitely do it in this way, accessing using the explicit index or maybe implicit index. Okay, then if you want at any point of time to set index with a column name, here in this case I'm setting the movie id as an index. All right, so in that also I can do it very easily with using the set index function, set index movie id. So you would see here the explicit index has vanished and movie id has become an index. And if you want to come back to where what we were earlier, just do a df dot reset index. That will again bring explicit index into the play. Okay, so that's how you set indexes and reset index for a particular data set. Then moving ahead, how to group and aggregate the data. Okay, so if you at any point of time want to group data, here in this case I've grouped the data by genre to perform aggregations like sum, mean, average, or in this case I'm performing only sum and mean. If you want to do average, whatever aggregation you want to perform, you can very well do it using df dot group by function. And inside the group by along with group by, you can use agg function, wherein you can mention on what basis you want to make an aggregation. Is it a mean, is it a sum, or is it a average? I have used these three columns on which I have done aggregation, that is IMDb rating. I have taken mean, that is I am trying to take average IMDb rating, and I am trying to look for total budget and total revenue that was generated per genre. This was my goal, and that's the reason I used this one. So let me check if I'm able to successfully get respective outputs. Yes, I did. Look at this action. For the genre action, this was the budget and this was the revenue and this was the average rating. Then for drama, this was the one, and for sci-fi, this was the one. So accordingly, whatever I try to group, the data would be generated. And so is it always necessary that you do aggregation for group by whenever you use group by statements? No, absolutely not, right? You may want in some cases that you don't want to perform aggregation, you just want to apply group by, so that also you can do, very much possible. And here I group it again by genre. This time I don't do any aggregations, but if I want to see a particular group, I need to use get underscore group function, and I would be easily able to see what is there in that particular group. So if I run this cell, you would see here I had used get group, and all the information or all the rows that are aligned with the sci-fi group are displayed over here, because I did a get group sci-fi group. Okay, so this is very much possible. Then what is next is hold on, let me just check. Yeah, df dot reset index, perform this df dot reset index again, and then what I do is apply function to data frames. Okay, so how do you apply a particular function? You know how to write function. We have studied this in our Python for beginner series. So this is a function with written with name profit underscore margin. Def is the keyword that defines. So this is a function definition basically, and it takes one parameter. That parameter is nothing but named as row. All right, what does it do? Returns row profit. All right, so whatever there is in profit column divided by revenue into 100. That is nothing but the formula to calculate the profit margin, right? And you want to calculate this for each and every row. So you would not be performing or writing this formula over and over again. Instead, you can very well use the apply function to the specific data frame and get the expected result. Now, this profit uh, margin will be calculated by applying the profit margin function, which you would see here in the apply function. The first parameter is the function name, and the next parameter is axis. Axis is equal to 1. That is, on every row in that column, the profit margin will be calculated. So if I try to look at the profit margin per movie, that's the reason I took title over here, and I'm easily able to see what is the profit margin that was achieved per movie as per our data set. So that's all about data transformation. Now let's move ahead with next topic. We will have a look at how to reshape a data, that is how to merge two different data sets. Then we will have a look at what is wide format data, what is long format data, and then we will also see what is pivot and melt functions, and then we will also have a look at how to stack and unstack the data. So let's jump in. Our first line of code, import pandas spd, as we already have done this before uh, on several occasions. Then I would like to show it to you that we have some sample data sets like movies, ratings, and NBA dot CSV sales data. These are the data sets we will be working on today, and we would see what are the various different outputs that we get when we perform various different joins when we try to merge the data. Now first I have loaded, or you can say I will read the dataset movies and ratings. So if you have a look at the um, movies dataset, and if you have a look at ratings dataset, you would see that there are two things. There is one thing in common, that is movie ID. On the basis of movie ID, we can definitely perform a join. Now, what is join? What is inner join? What is right join? So these come under the SQL concepts that you should be aware of to understand this video. All right. So I will, in the first case, join on the basis of inner join. To join two tables, here in Pandas, we have a function called as merge. You pass the name of the two tables, that is the left table and the right table, and you also have to mention on what column you are going to make a join, that is movie underscore ID in this case, and what kind of join, that is inner join, is something that you are going to perform here. So inner join, as we know, it displays the intersection part or the common part between the data sets. All right. So here you would see the output excluding movie ID 5, because movie ID 5 is there in the movies dataset. Look at this, but it isn't there in the ratings dataset. So you would not see that uh, movie ID 5. However, if you perform a left join, so whatever is there, I mean, all the rows in the left table should be displayed. Here in this case, the left table is a movie table. In movie table, we have these 5 rows. So accordingly, the 5 rows will be displayed and the intersection part as well. So you would see here in the output for left join, you would see here we have the common part as well as all the rows in the movies dataset. That's why you would see this movie ID 5. However, there is no data corresponding to the user ID and rating. That's why it is showing 9 over here. All right. And then moving ahead, on similar lines, we can perform right join as well, wherein all the rows from the right column will be considered and the output will be displayed accordingly. That's the reason you get such kind of a output. Then if you are aware of what is outer join, all the rows and columns will in the all the rows or columns that are there in both the data set will be displayed, eliminating the duplicate values. All right. So this is the output for the outer join. So here what I have done, I've used same merge function and same syntax and just modified the way I am joining. So whichever join you want to perform, you have to mention in the parameter how. All right. So that's about how to join the particular data. Now there is one another data set called as sales data, and it looks like this, that it has product, region, month, and sales. Now say if I want to convert this into a wide format data. Okay, so what is wide format and what is long format data? Wide format has got a column for each variable. Like in this case, say Jan, month of Jan, or say Jan sales or Feb sales, they will be considered as individual columns in wide format data. However, in long format data, we try to compact them as much as possible, and whatever we see here on the screen, this can be called as a long format data. So in most of the real world scenarios, long format data is preferred over wide format. However, for doing some analysis, maybe you find that wide format is suitable, then you may very well go with the wide format as well. So here what we are looking at, how to pivot a particular data set. Here we have got two functions in pandas for doing that, that is pivot underscore table and pivot. So if you want to use some aggregation functions along with pivoting, so you might be better off with the pivot underscore table. All right. Otherwise you can go for pivot function as well. So here what I'm doing in this pivot underscore table function is I will be trying to make this February, January, whatever the columns were there earlier. All right. Sorry. Whatever was there in the month, whatever the value was there in the month column, that is February, Jan, or any month you listed down here. Here it is only two. That I will try and put it in one in separate columns. All right, that is, I will make a separate column for Jan and I'll make a separate column for Feb, and I will calculate some aggregation, that is in this case I'm doing a sum. All right, that's the reason I get this kind of output. So your first thing, that is, you define what is the index that you want to keep. I have kept index as a product column as an index, and then columns month I am keeping is as it is. Then what I'm doing in that, values, I'm putting it as sales. All right. So whatever was there in the sales, I'm putting it in the value, and then for the columns, I'm considering month, right? So month where January and February. That's the reason they are looking here as individual columns, because you mention here that columns, what columns you want, whatever is there in the month, that we want it as a column, and then you do a aggregation, that is some average, what some or average, whatever you want to do, you can perform, and then you would get an output of such kind that it will display all the months that are there in our data. It's only Feb and Jan, so it will display that as an individual column, and they will have their sum of sales for product A and sum of sales for product B, which will be individually shown. So if you are looking really for this kind of output, you may go with performing pivot using this pivot underscore table function. All right, and converting it back to what it was original, we have a med function, and I've also used reset index over there. Now, when you convert it back, you need to mention what are when you mention these parameters, that what you are up to. So in the whichever you want to um, put it as a column, then you have to mention it over here, that id underscore vars. That is one parameter where you can mention the product column name, and then value, what value you want, that is Jan and Feb. All right, value means earlier it was Jan and Feb, right? If it were all 12 months, I will have to put those values over there, because those are the values that will be coming repeatedly in the month column. And what is the name of that variable? That is month. And what is the value name? That is sales, because ultimately you want to look out for sales for a month and for that product. Here you are not doing any kind of aggregation, and you are as well trying to shrink, or you can say make a data in a long format. You want to compact the data, and that's why you are getting this kind of output. The aggregation still remains the same, because you are pivoting on you are menting on what data set, pivot underscore data set. It is not the original one. Here you have the same sales and the same output, but you want to see it in this format. That's the reason you melted it back again to the format that you prefer, that is long format. All right, this data has been melted back. It's not about the original data. Please note these things, don't get confused. It's pretty simple. This was the original data. We did a pivot. We converted it into this. However, we felt that maybe the preferred format should be this one, because this looks pretty good for analysis, and that's why in some cases it might be that might happen that you feel that this is the better one, then you may well go with this. There is no issue as such. All right, then moving ahead, we have one another small data set, that is nba.csv, where we have this columns: name, team member, position, age, height, weight, college, salary, and all these things. And we want to do a stack. So stacking again is making or converting a particular data into just hold on, let me run this again. Yeah, converting a particular data into a compact form. If you would see here, whatever was displayed in the rows, that is, say this is the first row, this entire thing got compacted into one single index and in one column. That is very important. And instead of showing it as one row, it got converted into one column and in a single index. Okay, so similarly, you can now also unstack things to get back to the original format. Again, it matters which format are you trying to prefer. It's a wide format or it's a long format. Okay, now as a formal definition, it says that compress columns into hierarchical index and turn them into rows. That is what stack does. All right, compress columns into hierarchical index. So this is what was done earlier. They compressed all the columns into a single column, and they turned it into a hierarchical index. That for this one, what is the name, every Bradley, then what is the team, again the same hierarchy in the second row, again the same hierarchy in the third row, and so on, the entire data. All right, then unstack something is a reverse operation. If you want it back, again in the format that it was there. So you were able to achieve that as well. That is in its original format. All right. So you simply use unstack for that. Now let's see what is the concept of like multi-level index. So for that, what we have done is we have prepared a small data frame over here, which has got columns city, year, population, and area. Then what we have done is we have set columns city and year as a index. So this is how the data looks like when you set it as a index. Now you try to stack that data. If you try to stack, this is the output you get. All right. You use stack. There is a stack function to stack the data as we saw earlier. And this is how the data looks after stacking. So you would see why they're saying as a um, hierarchy or as a multi-level index, you would see here that new city and year, then that year again is divided into two, okay, and uh, two, that is 2020 and 2021, and in 2020 again we have two different things that those were columns earlier were converted here. So in 2020 what was the population and what was the area, in 2021 what was the population, what was the area, and this looks like a hierarchy, right? Because again for Los Angeles again it has its hierarchy, Chicago it will have its hierarchy. The data is not there for 2020 and that's why it isn't showing over here, okay. But that's the importance, what kind of data and in what way you want to have a look at it, so that it will be helpful when you analyze it further or when you try to draw some plots or visualize it further. So it's all about what are the questions you are going to solve or what exploratory analysis you are going to perform. Depending on that, you have to shape your data first. After shaping the data, only then you can go for your desired outputs. All right. When I unstack it back again, it goes to the original format, that is the one displayed over here. Okay, so that's how stacking and unstacking works. See these concepts like pivot, melt, stack, unstack, wide format, long format, it's very important to know, because ultimately what is our end goal, to perform some kind of exploratory analysis on this and generate insights out of it. So that's all about pandas, and I hope you were able to learn the concepts discussed in this tutorial of pandas, and see you in the next video. Until then, goodbye.